Alright, today in Algebra 1 we will be adding and subtracting rational expressions. Now this is where the x is on the bottom. Okay, so you do need to make sure that you have a common denominator, okay? Now the majority of the problems will have the common denominators for you, but for the ones that don't, I'm going to show you some techniques that actually work. Okay, so for example, you just want to check, is the common denominator, are the denominators common? And yes, they are on this one, so I can just add the top. Now when I add the top, I can't combine them, so I'm going to have 7x plus 5 on top divided by 3x. Okay, something pretty as simple as that. All right. Can I do anything with that? Can I simplify this? No, those are not like terms, so I cannot simplify this anymore. Can I divide the x by x and make that a 1 and make this a 7/3? You could, but now you're making the problem longer. It just depends on, what the problem's asking you. If it's asking you to simplify, just go ahead and add them and just go ahead and go on from there. Okay. All right, now this one, even though this looks really complicated and really kind of scary, it actually isn't. Okay, these two are both the same, so I can go ahead and subtract the top. Okay, now while I'm subtracting the top, I'm going to go 2x minus 5x, and that's going to give me negative 3x. And then negative 3 minus 4, which is negative 7. Okay, so I actually have the top. I can rewrite the bottom as x squared plus 5. Well, I'm not rewriting it, but I can write it and be done with it, and voila. There's my final product. Okay, now, if you notice on this one, 6x and 6x squared are not totally like terms. So what I want to do is, I'm sorry, not like terms, but common denominators. Okay, the common denominator between these two is definitely going to be 6x squared. Okay, so that means this one's only missing an x. Now, one time I was tutoring and the student couldn't grasp how to change the common denominator. So I said, okay, off to the side, write the fractions. So I had him write 7 over 6x. Now, he wasn't doing this. He was actually doing this with real fractions because I tutor younger kids. Okay, but I'm saying, okay, we're just changing the look of it. We're not changing the actual fraction. So what I did was I had him write a proportion, okay, and I had it have 6x squared on the bottom. Okay, now if you notice, there's something different here. There's a difference between the 6x and the 6x squared. Well, the only difference is that this one has an extra x on the bottom, so this on top, that needs to be a 7x. Okay, all right. Now I can go ahead and add those if I want, or I can rewrite it. It's totally up to you. Now that I have common denominators, now I can actually add the tops, which technically I can't because they're going to be unlike terms, but at least I am able to add them and go ahead and just rewrite the bottom as 6x squared. Okay. Now, are a lot of your answers going to turn out like this where you can't simplify? Yeah. Is that okay? Yes, it's totally okay. All right. Now, when you're adding or subtracting rational expressions, once again, do not simplify and find common factors and just work with it. Just leave the answer as is. Okay. Now, this one, the common denominator between z plus 3 and z minus 1. Now, some people have a really hard time seeing the common denominator on this one, and I don't disagree. The first time you see this stuff, you're like, what? There's a little trick in math that if you want the lowest common denominator, you can do it. But if you just want a common denominator, just multiply the two together. So z plus 3 and z minus 1. Okay? All right, and then I can rewrite these two. Okay, so what I've done is I've rewritten the two fractions and what I'm supposed to rewrite them as. Okay? All right, so if I take a look at this, I don't know what this is going to be, and I don't know what this is going to be. Okay, so let's take a look at the first one. All right, so right here I have 6 over z plus 3, and I have something over z plus 3 times z minus 3. Well, the only difference is I've multiplied by z minus 1, so I'm going to multiply the top by z minus 1 as well. Okay, so the top part is going to be the same. It's going to have the 6, but then it's going to have times by the z minus 1. Okay? All right, same thing here. I have 7 over z minus 1, and I have z plus 3 times z minus 1. So the z minus 1 is the same, except the z plus 3 times by is new. So if I'm just changing how it looks, okay, I need to have a 7 times z plus 3 as well on top. Okay? Right. Now that I have that all taken care of, it's kind of hard to rewrite it and stuff, but, well, it's not kind of hard because we already have it written down, but some students go, oh, I don't want to rewrite and add all this stuff. And let me change this to, I just realized that that was a 7x. Let's change that to a 7z. Okay. All right, let's change, once again, got to change this stuff around because I realized I missed out on the letter. Okay, there we go. Okay. All right, so now I have it. Now all I'm going to do is add the tops. I already know what the bottom is going to be. I know the bottom is going to be z plus 3 times z minus 3. So parentheses z plus 3, z minus 1 on the bottom. Okay, now on the top, I can go ahead and distribute this if I want. I'm going to have 6z minus 6 plus 7z squared plus 21z. Okay, and then I can start combining like terms. Well, obviously I want to write this in standard notation. So 7z squared plus 27z minus 6. You can try factoring this. I would recommend using Desmo. Okay, now now, after you get done factoring, plugging it into Desmos and finding out that this is not a nice, neat number, if this came out like its answers were 4 and negative 6, you know, something like that, you could factor the top and then see if you could simplify. But for right now, this is not factorable, so just leave it as is. So your final answer, and you are going to kind of have to ignore this stuff in here, okay, is going to be, well, let me just move it since I can do that. Is just going to be 7z squared plus 27z minus 6 over z plus 3 times z minus 1. Okay. Now, are you going to come up with a lot of these where you have to get the common denominator? No, but at least you have the tools and techniques to actually do this, and this will help prepare you for the second semester of Algebra 2, in which this is one of the harder sections to work with. Okay. All right. That's it for adding and subtracting rational expressions. I'll talk to you later. Bye.